Hello and welcome to Sustainable Talk, the podcast produced by young people for young people about the world of sustainability. My name is Eva, and today I'll be co-hosting this episode with Mike. Here at our podcast, we talk with leading professionals and change makers about what it takes to build a more sustainable present and future, sharing the stories, tips, and insights that will have you ready to take action, maybe even before your ice cream melts in this heat.
Yes, and we're really excited to have Amos Tai here today with us to share his take on topics of climate change, understanding how it works, and how the world can avert, mitigate, and adapt to climate change. Now, a little bit about Amos is he's currently an associate professor at the Chinese University of Hong Kong. Amos completed his civil and environmental engineering undergraduate from MIT, and he did his PhD in environmental science at Harvard University. He's one of Hong Kong's recognized academic expert voice on the topic of climate change. Hello, Amos. How are you?
Hi, how are you doing?
Where are you calling from?
I'm calling from my office in Hong Kong at the Chinese University of Hong Kong.
Cool, cool, cool. Glad to hear you're doing okay, Amos. Thank you very, very much for joining us today. We're really lucky to have you on Sustainapod today.
It's my honor.
Thank you very much. So, without further ado, firstly, a lot of our audience and even us, we have been born into a world that is experiencing rapid climate change, never really understanding how it works. So, to start off, can you please just briefly explain to us the concept and the science behind climate change, and even perhaps the feedback loops involved in climate change?
Sure, I'm very glad to. So, I guess one of the first things to clarify is the difference between weather and climate, because these are the two terms that the public would often get confused with. So, when we talk about weather, we're really talking about the day to day or even hour to hour variability of the atmospheric conditions. Maybe like today is hot, or tomorrow is raining, or this winter is particularly cold, or this summer is particularly hot. These are the things that are related to weather. So when we're talking about climate change, we're not exactly talking about the day-to-day variability or the year-to-year variability of weather conditions, all right? So if you say, oh, this summer is particularly hot or this winter is particularly cold, that is not a statement about climate change. Cannot say, oh, this year is warmer than last year, so climate is changing. You cannot say that because climate is the average weather over very long periods of time. So when you say long periods of time, we're really talking about at least 30 years, all right? So over 30 years, if you average these climate variables like temperature or humidity or rainfall, and then you really see maybe this 30 years climate conditions are actually the average weather conditions are indeed different from, say, 100 years ago, that 30 years, 100 years ago, then you can really say climate is changing. So when we're talking about climate change, we're really talking about long-term changes in the average weather and the way weather is varying year by year, right? So now we understand that climate is definitely changing. So for instance, in the current 30 years, the temperature is actually much warmer than, say, a century ago. Yeah, and this is have very solid scientific standing because we have observed it. We have used a lot of measurement. We are able to observe these very significant changes in weather conditions already. So, and if you're talking about climate change, like what is really shaping climate, indeed, global climate, there are mainly three major things that would shape climate. Three major things. The first one, of course, is how much radiation or how much energy in the form of radiation is coming from the sun. Yeah, that is definitely the most important because like most of the energy driving the climate system is originating from the sun. So how much incoming solar radiation reaches the earth is the first of the three important shaper of climate. The second one is how much of this radiation from the sun or this energy from the sun is reflected back to space by the surface of the earth that are bright in color. For instance, we have clouds, we have ice, we have surfaces that are lighter in color. These surfaces would actually reflect solar radiation back to space and thus not absorbed by the climate system. So how much such radiation is reflected back to space is very important. So for instance, if the more ice cover we have, then the Earth should be cooler because the ice would reflect more solar radiation away from the Earth. The same goes with clouds or other light colored surfaces. And the third factor is what you have already heard a lot about, greenhouse gases in the atmosphere. So the atmosphere has a lot of greenhouse gases like CO2, N2O, ozone, water vapor, and these greenhouse gases would, so to speak, trap the energy originating from the sun. They would they usually do it by absorbing the infrared radiation coming from the Earth's surface and then re-radiate such radiation back to the surface, giving the surface like an extra blanket of energy. So that is what's keeping the Earth's surface relatively warm. And so thus this amount of greenhouse gases is the third factors that contributes to climate. So when you talk about climate feedback mechanisms, right? So and changes, right? And when we talk about climate changing, usually we're talking about the changes in either one of these three factors. And the current climate change that we are observing right now is mostly caused by the changes in the amount of greenhouse gases in the atmosphere. So when you talk about feedback mechanisms, we're talking about how changes in one variable would lead to changes in another variable, which then leads to the changes in the original variable that started the change. So one of the most prominent example would be ice, the things that I just talked about, right? So if we emit more greenhouse gases into the atmosphere, that would cause the atmosphere to, with the Earth to warm up. As the world is warming up, then more ice cover in the poles would be melting, right? And just now I talked about how ice would help reflect solar radiation back to space. So if more ice in the polar regions are melting, then the Earth's capacity to reflect sunlight back to space is also reduced. And thus, we are absorbing even more radiation onto the Earth's surface. And that keeps the Earth even warming up more. And that is what we call a positive feedback mechanisms that would accelerate climate change, started by maybe something that we do independently of the climate system itself. So that is one of the example of climate feedback that is happening very rigorously right now.
Yeah, thank you for very insightful explanation. So obviously, like the whole system links, and as you mentioned, I feel like all the components are interdependent and leading to like this chain reaction, and we can experience it ourselves. So, from my experience studying in the UK, it has been snowing at a really weird time recently, even in March.
Yeah, yeah. I'm sure there's been a lot of frequent unusual weather in the short term. And just to bring this back to the idea of greenhouse gas and the positive feedback effect, just to wonder, since a lot of us were born with the idea of like, oh, global warming was already here, we were told by our parents that, oh, it's a good deed to do to turn off the lights, use less plastic bag. How were scientists actually in the initial phase back in history discover this thing that like, oh, this thing called climate change, that this thing is real? Did they actually look at the melting of ice in the poles? Was that the start of how they
So
discovered climate change?
that's a very good question. I think a lot of people have to ask this question because when they're understanding the concept of climate change, like they have to know how we actually know this is real, right? So first of all, well, we of course have a lot of observations, right? We go out there to measure the temperature. We have satellite images of the ice cover. So if you're talking about the changes in in the climate variables or in the climate systems, we have been observing them. Yeah, so they are of course real because we see them, right? You see them from our satellites. We go up. We have a lot of thermometers all around the world to check the temperatures. We know that temperature is really rising. Rainfall in some places have been increasing, while drought in some places have been worsening. So these are just observations, right? That we have already been seeing by collection of data. So these are not sort of arguable, or it doesn't need too much like validation because you actually measure them and see them, right? So this is happening really. But then the tricky part is to attribute those changes to what's really driving them, right? So how do we know this is not just because the sun is actually glowing brighter, all right? Or is it not just because, oh, the volcanoes are emitting more carbon dioxide, right? That it could be the reasons as well, right? So we have to rely on many other lines of evidence to know what's going on. So one of the lines of evidence is, of course, we have also been observing the sun. We have been observing volcanic activities, and we know that they haven't been changing so dramatically to affect the global climate over the past 100 years. Yeah, so these factors, of course, can change climate over very long periods of time, like millions of years throughout geological timescale. But for the recent climate change that is happening over the past 100 years or so, we know that the sun and the volcanic eruptions haven't been really changing that much. So they could not have been one of those important factors affecting the current climate change. Then is it really human activities? We then have other lines of evidence. So, for instance, we know biogeochemists know that the carbon originating from different processes would have different carbon isotopes. So isotopes are basically like different versions of the same element. All right. So some may be heavier than others because of the differences in the mass of their nucleus. So for instance, carbon has different versions, right? There would be, we call it carbon 12, carbon 13, and carbon 14, depending on how massive the nucleus of the carbon atoms are. So we know actually that by now that some processes would create carbon dioxide that would have a high, heavier carbon atoms, and some processes would have much lower carbon atoms. For instance, fossil fuel, the carbon in fossil fuel actually usually would have a bigger amount of the lighter version of the carbon atoms. And what we have been seeing in the atmosphere is that the atmospheric CO2 is actually getting lighter and lighter over time. All right. So we know that the CO2 molecules themselves are actually getting lighter. And then the only reason is because can only be attributed to the more of such carbon actually coming from fossil fuel. So that is one of the key lines of evidence. But another, I would say, even more important lines of evidence is actually computer modeling. Right. So we cannot do experiments on Earth like we do in a lab for physics or biology or chemistry, right? So for Earth sciences, oftentimes we cannot really do experiments on the real Earth because we only have one Earth to live on, all right? We cannot play with it. But what we do instead is to simulate the Earth in computers, all right? So in the computers, we put in all of the processes that we know are happening on Earth, the physics, the fluid dynamics, the thermodynamics, the chemical reactions, and everything that we now know shape the Earth's climate and the Earth system, the Earth's environment into representing them in mathematical equations and then coding them into the computer. So the computer is actually simulating what is happening in the world. And then, we can use the computer models to do experiments. So we can, if we only include natural factors like the sun or volcanic eruption, or if we also include factors like human emission of carbon dioxide through activities, fossil fuel combustion, agriculture, so on and so forth, what would be the simulated climate or simulated temperature? What we found is that by only including human emitted CO2 and other greenhouse gases, can we reproduce the observed temperature, from the computer simulations? So that's another very important line of evidence telling us that it is really human activities that have shaped the current climate change.
Wow, that's very insightful. So you mentioned that we have to measure those different aspects to gain a more comprehensive and accurate understanding, and especially to isolate sort of the human activity as a variable. So I just want to ask that you mentioned our activity with the use of fossil fuels, which increases CO2 molecules. Is there sort of a time lag between when the CO2 is released into the atmosphere from fossil fuel combustion and when the full impact on the global temperature is realized? Would there be a time lag of sort of many years for the full effect to show?
I think I would say instead of talking about time lags, right? Basically, once CO2 or other greenhouse gases are emitted into the atmosphere, they will exercise their greenhouse effect and start changing climate, right? So the impact is almost like immediate, but of course it takes time for the full scale of effect to take place because you have the climate system is, takes time for the energy to build up and to redistribute and so on and so forth. Yeah, so the most important points about greenhouse gases is that they are long lived. That's it. That's why they're greenhouse gases. They stay in the atmosphere for a long period of time, usually at least a few decades to a few hundred years. So once they're emitted into the atmosphere, it actually takes a long time for them to be removed from the atmosphere. So they would be able, once emitted, they can exercise the greenhouse effect over a few decades or even a few hundred years. So for that, what that means is that even if we cut down greenhouse gas emissions right now, the historically emitted greenhouse gases would still be exercising their effect for the next few decades or centuries. So the effect of climate change is long lasting and it will continue to exercise. It cannot be removed or reversed in a short time scale.
Okay, like you said, we can see that climate change affects all aspects on Earth, from the ocean to the terrestrial ecosystem and the atmosphere. Which impact do you think right now is most concerning, and why?
I would say things that we human beings usually care about would have the biggest sort of implications for our socioeconomic systems and well-being, right? So I think one of there are really many impacts of climate change that are worth worth concerning about, being concerned about, really. But some of the bigger impacts that we are already seeing would definitely be on for instance, the global food systems and poverty and malnutrition that come from that. This is one of the aspects that I personally have looked at before. And indeed, in some previous research of ours, together with, of course, many other studies as well, what we found is that climate change is going to greatly threaten future global food security because heat temperature extremes and things like drought or floods, they really destabilize the agriculture systems, making a lot of places that heavily rely on agricultural production and the people who rely on agricultural productions for their livelihood and also everyone that need food to survive to be at risk. Yeah, so but those regions that are most hard hit are usually tropical and subtropical countries and regions which are usually poor to begin with, and they have very little resources and to really fight the impacts of climate change. So I would say the climate change right now is sort of almost unequally affecting tropical countries or countries that are relatively poor to begin with much more than many other more developed countries. And people in those countries, many of them are farmers. Their livelihood are greatly affected by climate change. For instance, in some Central and Eastern African countries, a lot of the farmers are really feeling the threat. Like their livelihood is greatly destabilized and they cannot have a reliable source of income and also a source of food as well. This is already happening, destabilizing the economic system as well. Another impact, of course, is the rising sea level is really hurting a lot of coastal regions and island nations. Yeah, their lands are basically being inundated by seawater right now, and the coastal regions are shrinking, and that would cause a lot of also destabilization of the economic systems as well as the populations, basically driving out people, causing people to have to move around to other places to find a better livelihood. This is already happening in many other places, in Africa, in South Asia, and in many island nations. So these are hugely destabilizing factors that are already affecting a lot of the poorer nations in the world. Yeah, so I think these are some of the most important aspects. But in a sense, people in cities like richer cities like Hong Kong or UK, in more developed regions, are still feeling the threat because we see rising food prices every day, and that is affecting the lower income families in these places. Yeah, and from time to time, our cities would also feel a lot of heat waves, droughts, extreme temperatures. Extreme temperatures is actually something that can really have a great impact even in developed regions. Yeah, because Everybody, of course, don't like very hot weathers, but what is really bad about temperature extremes is that it can greatly worsen pre-existing health conditions. All right, so a lot of people who are already weak to begin with or sick to begin with cannot really stand extreme temperatures. Yeah, and extreme temperatures are really causing a lot of fatalities these days.
Right, that's a very, very insightful answer, Amos. And I was born and raised in Thailand where there's extreme inequality, and agriculture is one of our top sector in our country. And I can totally relate to what you're saying, and I can see how the farmers and the poor people are actually suffering more from this problem rather than I would say richer people or people who are well better off working in the tertiary sector. What do
Yeah,
you
to supplement that, another big impacts of climate change, of course, is the extreme weather, right? Like the hurricanes, the typhoons, the rainstorms and floods. These are usually like it doesn't happen all the time, like continuously, right? Like hot temperature is like the whole summer can be hot, and then people really dying from the heat stroke and stuff. But usually these extreme weathers like happen from time to time, and the frequency of these weather extreme would be increasing in the future. And of course, countries like the Philippines, even without climate change, they are hit by typhoons like almost every year. But now with the rising frequency and intensity of these storms, their poorer neighborhoods and people really living in coastal regions can be really at risk when these disasters happen.
Yeah, I totally agree. And as you mentioned, there's definitely almost like a regressive effect of climate change on the most vulnerable population. And obviously, the social economic impact needs to be taken into account of, and it will have major consequences for the government's decision making and the setting of sustainability goals. So the problem is really scary, and I would like to know how we can combat it. So with that in mind, is the goals currently we have to keep the global surface temperature well below 2 degrees Celsius above the pre-industrial level. Would this goal be achievable? Is it enough?
Well, basically, what we all agree, climate scientists and policymakers all agree is that we want to uh, limit warming as much as possible. Yeah, so it's very hard to say what is enough and what is not enough, right? Like, we know that we really want to keep temperature below 1.5 degrees Celsius above pre-industrial level, right? And that in that if we do that, if we are able to do that, then climate state can be stabilized at pretty much like the current level, maybe a little bit worse than now, but at least we can stabilize it. Now we are already seeing a lot more wildfires and natural disasters and heat extreme. But right now we're handling them, we are trying to tackle them and adapting to them. If we can keep 1.5 degrees Celsius above pre-industrial level, then we are kind of facing the situation that we are kind of already facing now. So, it's still kind of manageable. But 2 degrees Celsius is a lot worse. Yeah, it's already a lot worse than what we have already seen right now. Yeah, so 2 degrees now, global temperature has already risen by 1.1 degrees Celsius. Yeah, 1.1, nearly 1.2. So 1.5 is it will be reached pretty soon, actually. But we want to keep it well below 2 degrees Celsius. I would say this is a very challenging goal. But this is definitely doable if we have good coordination. There are a lot of good signs happening already. So many industries and businesses are really already talking about ESG, carbon credited, carbon offset. And I think a lot of the businesses and governments and civil society are really on board to uh, together fight these issues. Yeah, it is very, very challenging, of course, but I do see momentum. The electrification of the vehicles are really happening at a fantastic rate, really. Yeah, you can see, for instance, mainland China, a lot of cities have very, very rapidly switching to EVs already. And we are also, many countries are also gradually moving towards more and more renewable energy in their energy mix. So I do see a lot of momentum going in from many different sectors. So I do think keeping temperature below 2 degrees Celsius are very challenging, but I do see signs that it is moving toward that direction.
I see, I see. You did say that if we reach 2 degrees Celsius, all hell will break loose. It will be really,
No,
really
not yet, not yet. Two
not
degrees
yet.
somehow like,
Okay, okay,
well, maybe we 2 degrees a lot worse than right now.
okay.
Yeah. So, but then this is not the worst case scenario that that is possible. The worst case scenario is somewhat more like 4 degrees Celsius or even 8 degrees Celsius. That would be like complete hell, like returning to the state of, the dinosaur age almost.
Yeah.
Yeah, where basically all ice has melted, and basically we're living in a place where, everywhere is hot. So yeah, I think 2 degrees is kind of like it is livable, but then we have to do a lot of adaptation in our socioeconomic, agricultural, food and energy and water systems to adapt to a world with 2 degrees Celsius above pre-industrial level. Yeah, we do have to do a lot to adapt to that world, but it's not the worst. The worst would be somewhat like 4 degrees Celsius, which is actually possible, if we don't do anything to help with cope with climate change. Yeah, so if we just keep, emitting right now, just carry on. Let's say we don't even care about climate change and just let businesses and developing countries grow and populations keep rising. 4 degrees Celsius is totally foreseeable, and it's still is absolutely likely. Yeah, so 2 degrees is not the worst. We are trying to keep it below 2 degrees.
Yeah, so then I guess on the more positive side, so in an ideal situation, as you said, if we stop or limit all the greenhouse gas producing activities today, although we will still continue to see the global warming effects perhaps for decades to come, but how many years will it take to perhaps convert the global temperature back to a level like before all the anthropogenic global warming?
Okay, so even if we stop right now, right, the temperature is still gonna rise by for some time. Okay, even if we stop emitting greenhouse gases, even starting now, right, that would be the best case scenario, like absolutely best case scenario, right? So temperature would still rise in the next 2 decades or so. Okay, finally stabilizing in about 2050, all right, stabilizing at about 2050, and then it would gradually drop a little bit, but then it won't go back to the pre-industrial level for many, many, many hundred years. Yeah, so so in a sense, climate change is in this time scale, in the time scale that we're living, or we are living to see, or just in a couple of generations, climate change isn't really reversible. It takes like hundreds to thousands of years for temperature to actually reach back to the pre-industrial level. When the Earth system gradually take those greenhouse gases back to the ocean and maybe ultimately to the sediments. So yeah, I would say in the foreseeable future, it won't return to the pre-industrial level, but it can be stabilized at a certain level that is higher than the pre-industrial level. That would be the best case scenario already.
I see, see. So, what are your thoughts on some of the new innovations that are starting to rise up, like the capture technology? And do you think it's going to be a significant contribution to mitigate the climate change?
Well, this is that is really beyond. I mean, this question itself is beyond science, right? A lot of it has to do with the economic feasibility and policy and framework, engineering solutions, and things like that. From what I have seen and read, I can say that these like carbon capture technology, really trying to take carbon away from the atmosphere, or once we emit it, we capture it and then pump it into the ground, maybe depleted oil reservoirs or some other geological reservoirs, right, or into the deep ocean. A lot of these technologies are plausible, but they are not scalable to be enough to actually tackle the problems. Yeah, for the foreseeable future. So I think they can be valuable in terms of helping address the issue a bit, but they cannot be relied on completely to reverse climate change or to just mitigate climate change to a certain level or keep climate change to a certain level. Yeah, they can be part of the solutions. They cannot be the majority of solutions. The majority of the solutions should still be a complete transformation of the economy, which has been depending a lot on fossil fuel, and we have to switch that to become reliable instead on renewable energy. with much less energy use by basically switching to a more high energy efficient economy in all sectors, by turning to a more plant-based diet instead of a very heavily meat-based diet with a lot of processed food processing, which are all energy consuming. Yeah, we have to basically change the way we eat. The whole economy depends on energy in order to really mitigate climate change. That should be the majority of the solution.
Yeah, I totally agree. So we have to, of course, it's impossible to convert it back completely. So we're trying to mitigate and stabilize climate change, and this will definitely require our collective action. And since that you teach and work in this field with a lot of students, do you have any tips on how we can scale climate education, particularly for young people, and what are the effective avenues to engage in?
I think the first thing I would say is to not lose hope. Indeed, we should have a lot of hope because, I already see a lot of hope in how fast some technologies like electrification of vehicles and the transformation of their energy system have been happening across the world already. So I think for young people, yeah, out there are a lot of sort of a rhetoric that is either very like doomsday kind of rhetoric. Yo, the world is ending, and if we don't fight climate change, we are all gonna die, or ecosystems are gonna collapse. Well, I mean, we're not all gonna die, but ecosystems collapsing are true, are real. Yes, the picture can be bleak if you really look at the consequences. 99% of coral reefs are going to break down, very likely. But then I would really say no, we don't. We do not want to always focus on these like things are happening. Okay, so these are happening. We should stop it. But at the same time, there are a lot of hope. What the world is really getting together to deliver solutions. Maybe not at a pace that as fast as we would have wanted. But this is happening, and then everybody can actually play a role in it. So instead of feeling very negative or pessimistic about it, I really want young people to stay hopeful. I think hope and joy is really part of what's driving the solutions. Yeah. So and this should be the rhetoric. We are really seeing people from different sectors coming together. And so instead of looking at the very bleak pictures, which of course can happen if we don't do anything, but the honest fact is people are doing something. Yeah, and everybody can do something to fight climate change.
That sounds really good. And I truly believe that being hopeful is the first step to transitioning anything or achieving anything. And apart from that, do you think there's anything that teenagers or children, our audience mainly, or people at our level as like a kid or students can do to contribute towards like limiting the carbon footprint? Is it the go to using less plastic bag? Is it turning off the lights, or would you recommend anything else?
Well, first of all, I think like talking to their parents, talking to your parents and the adults about it, like really showing how concerned you are as someone who will inherit the earth in the future. Then having them having this like pushing the adults and the parents to have the sense of urgency, because like what they're doing right now actually affect your future. So I think many parents would care about their kids, right? So making parenting, or educating the younger generations, like everyone, who have kids, or we all want the next generation to benefit, to have a better well-being. All right. So emphasizing how the young people are demanding the people now in power or in businesses to do something to such that they can inherit a more livable world planet in the future is something that the youth can do because like no other people can tell the parents to what they should do. It's really just their kids, their offspring, their next generations who really voice this out. So I think young people have this strategic role to play. Because you will inherit the earth. You have every right to voice out how much you need changes to be happening. Yeah, because you will be living in the earth and living with the problems that most of you didn't exactly cause. So I think that is one perspective that young people can really focus on. This is kind of like addressing the issue of intergenerational justice, right? And but then on a day-to-day basis, on an everyday level, I think, yeah, of course, yeah, young people as well as other people and just older people can have a lot to do. One of the things that I often talk about is to pay attention to the thing that you eat. Yeah, indeed. Your the food system is responsible for 1/3 of the greenhouse gas. Yeah, so even if you completely go energy efficient and then using renewable energy, blah blah blah, there's still a big chunk of greenhouse gases that are coming from the food system. Yeah, not yeah. So those would be because the use of fertilizer, the cattle and ruminants giving off methane, and clearing the forest in order to grow food. All of these things can emit carbon dioxide and other greenhouse gases. So paying attention to the way we eat, right? Try to eat as little meat as possible, only the amounts that you need. A lot of people in developed regions and cities and countries, they eat a lot more meat than they actually need. Yeah, so reducing meat consumption, which would also be good for the health, especially reducing red meat consumption, trying to substitute protein, meat-based protein to plant-based protein, and also really looking at where you're getting the food. You want to reduce the mileage of the food, right? You want to buy as local as possible so that the transportation emission can be reduced. A lot of these things, and pay attention to where the food is from. Is it from like fair trade from fair trade farms? And also whether the product behind is causing a lot of deforestation. You can always pay some attention to it, and gradually switching to a low carbon diet. That would actually really help. That is something that everyone can do every day. But of course, reducing energy use, public transport, and so on and so forth, encouraging your parents to switch to electric vehicle, all of these things can, of course, would help. Yeah.
Yeah, thanks a lot. So I am definitely taking notes on what we can do in that case. Thank you so much, Amos, for joining Mike and I today on this very special episode and for sharing your insights. It's definitely good to know that there's still a very hopeful future. And personally, my key takeaway from this is that we are sort of the stewards of the earth, so we have to take the stewardship and do as much as we can to build a more sustainable future.
Absolutely.
I can't agree with Eva more. And again, thank you, Amos, and thank you, all you listeners out there, for tuning into Sustainapod today. We hope this discussion has taught you a thing or two and inspire you to take some action yourself.
Thank you
As
so much.
always, thank you so much, Amos. And as always, we would love to hear from you about this episode. So let us know your questions and comments via Instagram at sustainapod_GIH or email us at sustainapod@gmail.com.
Goodbye, and thank you
Goodbye
for
and thank
listening.
Bye.
you.
Thank you.
Bye.